Section 5.1, essential question, how to use exponents to simplify or evaluate an expression. Here are the properties of exponents. Again, you can pause this and write these down if you need to. You get the product of properties where you have the same base, different exponents. You add the exponents. You got the power of a power. When you have two exponents, you multiply them together. When you have power of a product, it's almost like the distributive property. You put the exponent with each product. Negative exponent, whenever you have a negative exponent, we'll kind of talk about the rules about that maybe in class a little bit more, but if you have a negative exponent, it makes it the reciprocal. So a to the negative m is equal to 1 over a to the m. It does not make it negative, which is a common mistake a lot of people make. A to the 0, anything to the 0 power is 1 except for 0, and we can talk about why that is in class as well. When you have the same base, different exponents, and you divide, what you do is subtract the exponents. So it kind of has a relationship. When you have the same exponents, you multiply and you add. When you have the same base, different exponents, and you divide and you subtract. And the last one, power of a quotient, is very similar to power of a product. If you have a quotient and you have an exponent on the outside, you put that exponent with each part on the top in the numerator and the denominator. Okay, so first one, simplify each expression completely. You just want to add the exponents together. So negative 4 plus 6 is 2. 2 plus 7 is 9. That would be b to the 9th. Okay. Pretty easy. Again, I'm not very good at writing this, so, bear with me. This one, we have negative 2. What we're going to do is, when we have power, multiply those two. So negative 2 times negative 3 is positive 6. So we have r to the 6 over, and we're going to multiply 3 times negative 3 and get s to the negative 9. Now, one of the rules for this is you cannot leave it as a negative exponent. So whenever you have a negative exponent, if it's on the bottom, if you have a negative exponent on the bottom, to make it positive, you have to do the reciprocal, which moves it to the top. So in this case, it would be r to the 6 s 9. Okay? And that would be the answer for this one. Okay, so whenever you have a negative exponent on the bottom, you have to move it to the top. Now this one, I would just work left to right. You got 16 divided by 2, which is 8. Okay, we got m to the 4th. Okay, and then we have negative 5 minus, remember when we divide, we subtract. So you end up with negative 5 minus negative 5. Okay, so minus a negative makes that a positive, so it ends up being negative 5 plus 5, which gives you 0. So you end up with n to the 0. But on the other page, we know that anything to the 0 power is 1, and 1 times anything is just itself. So it ends up the answer being just 8m to the 4th on this one. Okay. So make sure you're careful. Whenever you divide, you got to subtract. So negative 5, that division sign is like a minus. Negative 5 minus negative 5, which makes negative 5 plus 5. Or basically, anything divided by itself is 1. There's another way you can think about it as well. Okay, or those are the same, so they just cross out. That's another way you can think about it. Okay. So this one says, what is a simplified form? The first thing you want to do is distribute this exponent to each of the ones on top, only to the ones in parentheses. It's not the 2, the whole thing's not in parentheses, so we're not going to move the 2 down here with the 5 and 6. So we'd have x to the negative 6, and we'd have y to the 6 over x to the 10th, and, or sorry, I did what I said I wouldn't do. You don't distribute it to the bottom. So x to the 5th and y to the 6th. Okay, from there, remember what we do is, there's a couple different ways you think about this, but the way I'm going to do it is just subtract negative 6 minus 5. So negative 6 minus 5 is negative 11, so I have x to the negative 11. Okay, and then y over 6 over y over 6, that's the same thing. 6 minus 6 is 0, and then 0 power is 1. So he cancels out, or you can just think of they're the same thing, so they cross out, however you want to think about it. Again, we can't leave it as a negative exponent, so what we have to do is write the reciprocal. The reciprocal is 1 over x to the 11. So if you have a negative exponent on top, or if you think about this as over 1, you have to flip it upside down if that helps to think about it that way. Okay? But if you have a negative exponent on top, you need to move to the bottom. On the other one, you had a negative exponent on the bottom, so we had to move it to the top. But that gives us the answer of B, 1 over x to the 11. Okay? Another problem. Okay? We're going to distribute. And this time the parentheses over the whole thing, so we're going to distribute each part. Along with what a lot of people mess up is you also got to put the 3 with the 2. Or so it's got to become 2 to the third. A lot of people forget to do that, and that messes them up, so make sure you do that. And then you got to put the 3 with every single part. So the top one would be a to the 6. And then you'd have b to the negative third over 2 to the third, which would turn out to be 8, but we can do that later. And then 3 times 3 is 9. Remember, we're multiplying all these. Okay, and then b to the 6. Okay. So then we just got to start simplifying, okay? I'm just going to rewrite it. Well, there's a couple of different ways you can think about this, okay? First, let's look at 2 to the third. 2 to the third is 8. 2 times 2 is 4. 4 times 2 is 8. So let's do that first. That's 8, okay? 6, what I like to do with these when they're both positive is we're finding a difference when we divide. We subtract them. So the difference of 6 and 9 is 3. But there's more on bottom than there is on top. So where I'm going to put the 3 positive ones is on bottom, okay? And just write it as a to the third, okay? Another way you can think about it as 6 minus 9 is negative 3. And I would have to go on the bottom to make it positive. So either way, a to the 3 is going to go on bottom. But that's kind of how I like to think about it. The last one is already a negative. There's a couple ways you can think about it. 6 here. Again, we got to bring those 3 negatives. If it's 3 negatives, you got to bring them to the bottom. So if you bring the 3 to the bottom, now you have 6 plus 3, which is 9. Okay? And since nothing's left on top, we have to have a placeholder of 1. So it'd be 1 over 8 to the third b to the 9th. A couple different ways you can think about that. Negative 3 minus 6 is negative 9. And since it's negative, you got to put it on the bottom to make it positive. You could do, you could move the 3 to the bottom. So it'd be b6 and b3. And then 6 plus 3 is 9. That's another way you can think about it. Multiple ways to think about it, but either way, you should end up with b to the 9th on the bottom, whether you just subtract straight from here and do negative 3 minus 6, or if you bring the 3 down and have 6 plus 3. But either way, this should be your answer. Okay. So whatever's easiest for you. Okay, scientific notation. You've done this before. C, the most important thing is C has to be between 1 and 10. It has to be less than 10. It could be equal to 1, but it has to be greater than or equal to 1, but it has to be less than 10. So 9.9. Basically, it has to be a one-digit number, okay? Or it has to be in the ones place. So how we do these is we rewrite them as we're going to multiply the like parts together, like 4.2 times 1.5, and then multiply the powers together. Because remember, we know that if we have the same base, different exponents, when we multiply, we're just going to add them. So we're going to do 4.2 times 1.5, which is 6.3. So we got 6.3 times 10 to the, and then you just add the exponents. 3 plus 6 is 9, so 6.3 times 10 to the 9th. Make sure I did that one. Yeah. Okay. So that'll end up being our answer on that. And if this number was bigger than 10 or less than 1, then what we'd have to do is change it somehow to make it work the right way. But in this one, we don't. We're good on this one. Okay. Next one, we got 8.1 divided by 5.4. Again, we're going to divide these two normally, and then we're going to divide these two. But all we got to do is, instead of the same base, different exponents, is subtract the exponents. So we're going to do 8.1 divided by 5.4, which equals 1.5. times 10 to the 12 minus 9 is 3. So that would be your answer. Okay. So that's all you have to do. Again, these are pretty easy. We'll have to maybe go through some problems where this number is not between 1 and 10. We have to move it later. Okay. Actually, this one here right now. Okay. Says swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in a swarm? So 85 million locusts per square kilometer, and there's 1,200 square kilometers. So what we have to do is multiply these two numbers. So 85 million times 1,200. Okay, now we could just multiply this in our calculator and be done. But they want this as scientific notation, which makes sense because we don't want to write these gigantic numbers. So let's rewrite this as scientific notation. So how to write this as scientific notation is move the decimal point over 1, 2, 3, 4, 5, 6, 7. So I would get 8.5 times 10 to the 7th times, so 1, 2, 3. Basically, all I'm doing is making the number between 1 and 10. So 1.2 times 10 to the 3rd. Okay. So I make the number, I made 8.5 between 1 and 10. I made 1.2 between 1 and 10. Then we do the same thing with the other one. 8.5 times 1.2. It's 10.2 times 10 to the, and now we all do is add the exponent. 7 plus 3 is 10. Now, on this one, move this down. On this one, our number is not between 1 and 10. It's bigger than 10. So what we have to do is there's different ways to think about this. But one way to think about this is 10.2, if we wanted to move it decimal point over 1, would be 1.02 times 10 to the 1. Okay? Because, 1.02 times 10 would be 10.2. So basically what we're doing is moving it over, and just like we did here, moved it over 7 times, we got 10 to the 7th. Moved this over once, got 10 to the 1st. And then we still got times 10 to the 10th, which is just from over here. Okay? So then, basically our answer is just, what's 1 plus 10? Because we multiply, we add the exponents, it'd be 11. So our answer would be 1.02 times 10 to the 11th. Okay, that's how the book kind of explains it. The way I like to do it is just say, okay, am I making this number smaller? If I'm making this number smaller, I got to make this number bigger. So how many times I move this number to make this smaller, I got to make this that many bigger. So if I move it twice, I have to make this 2 bigger. If I move it 3 times, I got to make this 3 bigger. If I make this number bigger, then I got to make this number smaller. It's kind of the way I like to think about it, but either way, whichever helps you get this, understand it, it's fine with me. Okay, we can do these in class and talk about the examples in class. Again, must always finish these, show me before you can leave class. Okay. And that is it. Thanks.